All right, so I'm gonna go through this. Uh, the answer for this one. So I'm gonna go through as fast as I can. You let me know you need help because I'm pretty much gonna go over all the questions. They're all pretty important. Um, Now, like I say, you gotta do so here. Which quadrant would it be? Oh, sorry. Huh? Which one? Which quadrant is this? Arvin? Which quadrant? Uh-huh. Four's correct. This is a check, this check, this double check here. Here? 3 and 5, right? So the answer is this is -3, so cosine is gonna be 4/5. Is that okay? Pretty easy, right? Cosine -3/2. This, I think. And there's a 2, there's a 3. What is the third side here? √5, good. And this is negative. So cotangent is equal to what? Okay, good. This one's kind of tricky for a lot of students. This is here. So it should be -4 and 1. Is that okay? And that's square root of what? 17. So that is going to be what? Secant. So square root 17 over 1. See, this is not hard homework. This is easy. Negative, I think. 5, 13, 12. This is a 5, 12, 13 triangle. 13/12. Good. 1/5. So this is like a speed run. 1, 5, square root 24. Theta. Tangent is going to be 1 over square root 24. Is that okay? Yeah. Speed run. Here, 1. And what? 3. And this is negative. So square root of 10, I believe. So cosecant is what? Yep. Perfect. Triangle. 4x, 5. Um, so we're going to call this side z. So 4x squared plus z squared is equal to 5 squared. So z squared is equal to 25 minus 16x. Good. The z. Okay. So then secant is what? 5 over 25 minus 16x squared. Now, please do not break math here. Some people says 5 over 5 minus 4x. That's wrong. You'd never want to simplify the radical inside two term like that. That doesn't make sense. Do not break it in. That is bad. Triangle. Um, 2x, 3, right? So that's z. So z squared plus 2x squared is equal to 9. So b z is equal to 9 minus 4x squared square root, right? So cosecant is 3 over root 9 minus 4x squared. Hopefully, so far, no questions. This is all pretty easy, pretty standard. Triangle 2x z. So z squared equal to x squared plus 4. Z equal to square root x squared plus 4. Secant is going to be x squared plus 4 all over what? X. And I think we did this one already. Oh no, we didn't. This is 12x 13 squared, so 169 minus 144 x squared. Is that right? Cotangent is 12x over square root of 169 minus 144 x squared. Is that right? Oh, easy. This one, everybody have the questions. So, everybody's always like, can I do number 8? But okay. It's not that bad. I don't know. If you watch a video, can tell you. Which one? Which one are we go over? F? Okay. Okay, so understand the location 11 pi over 8. Which quadrant would it be? 11 pi over 8 is third because this is 8 pi over 8. This is 16 pi over 8. 11 pi is closer to 8, right? How close? Huh? 3 pi over 8, right? Does that make sense? So this is 11 pi over 8. Now, you wanted to cosine inverse, so it has to be the top two quadrant and has to be in this quadrant. So if this opening is 3 pi over 8, then you take account from here to here, therefore 5 pi over 8. Understand?
That's slightly different word instead of just, I mean, it's basically the same thing. Instead of doing a shortcut with 3 pi over 8, I had just done 2 pi minus to go to 6 pi.
Yeah, it's fine. Yeah.
I understand what you're doing, but like when you said like stuff, I get a little confused how you use it.
You need to be more specific. What do you mean?
Like when you said like living it.
Yeah, because basically this is gonna give me a some type of x value, cosine or whatever, which is this x value right here, this value here. But we don't need to care about that value because we're gonna cosine inverse of that x value. So we should go back to some type of radian, some type of angle. But the angle has to fit in the quadrant, on the top two quadrant, because cosine inverse have top two quadrant. So it's kind of as like, I cannot think of a good analogy, but basically you should get back to original angle, and that angle has to fit into cosine inverse, result the same thing. So I'm just gonna give you an answer for all of them. I think this is 2 pi over 5. Is that okay? Because that's on first quadrant, give you the same output. This is 3 pi over 5, I think. Is that okay? 7 pi over 5 is negative 2 pi over 5. This is actually 2 pi over 5. 5 pi 5 pi over 8. Let me see. 5 pi over 8 is 3 pi over 8. Negative pi over 5. Pi over 5. Catherine, you feeling better? What can I help you?
I think I just like did everything wrong. All
Do you need help with any questions? Yes.
question is since it was sine inverse, it would have to be within like the parameters. So I have a lot of them split. So I don't know.
Tell me which one.
For A, put it as negative pi over 5 by
Okay, so first of all, I always figure out a quadrant first. 3 pi over 5, which quadrant is that? Right, because this is a 5 pi over 5, right? So it's gonna go back. This 2 pi over 5. Would you say this is a 3 pi over 5? Is that okay? But you know sine inverse has to be either this or this, right? But since you want the same output, same sign, so this has to be this. Now, if you know this opening is 2 pi over 5, so this goes 2 pi over 5 here. And that's how you get 2 pi over 5. Huh? I see this opening because from 5 pi over 5 to go back to 3 pi over 5, it's 2 pi over 5, right? Yeah, so the opening is 2 pi over 5. So it'd be, you just add, you just go to the first quadrant to have the same opening. And that's going to give you the same triangle as the other side. For me, I just look at the opening because opening is tells me that's a reference angle. So the reference angle of 3 pi over 5 is 2 pi over 5. And I just need to figure out first quadrant with the reference angle, which is 2 pi over 5.
Alright. And then negative 5. Yes, because of our game. Alright. Okay, thank you. Let me just write it off. You got things.
Jack, Thing, Abadash, you guys doing okay? Abadash, you okay? Alan, do you need me to go over one more? Catherine? Ethan's like, I just very logical.
Luckily, I have Maddie in my class, so I
Who?
Matthew.
Sheldon?
Yeah,
I love Matthew. Matthew is such a great person. Yeah, he's a football player, linebacker. I love Matthew is because he has the same name as Big Bang Theory, Matthew Sheldon. I love that. And he's also bright like Matthew Sheldon. All right, so let's go to equations. A lot of you guys are understanding equations, so I give you some analogy of on the board. I actually told people multiplication table is a unit circle. So unit circle, right? I already told you this is the first stage. I will teach trig. I always go with those 4 stages. Second stage, I will teach people about formulas and stuff like that. But at the same time, I will teach them says, okay, multiplication table. I will tell them, well, what is 6 times 7? And you can tell me that's 42. But unit circle side, I would ask you what is 6 sine of 7 pi over 6? And I would say, okay, that's equal to whatever, right? That's equal to negative 1/2. So we already gone through the second stage. We already gone through the third stage. So for example, 42 is equal to something times 2. Then I restrict itself has to be something times 2, not something times 6. So therefore, there's some type of restriction in play. And therefore, this one has to be 21. But for here, it's probably sine inverse of negative square root 3 over 2. So the answer is what? Negative pi over 3. Good. 4. This is the last stage. So I can say 42 equal to what times what? That becomes a lot of options. Trick question. How many options are there?
If you're counting decimals and fractions. I feel like I'm wrong, but at the same time, I'm pretty sure.
How about just integers? No. 6.
Yeah, 21 times 2. 2 times 21. 6 times 7. 7 times 6.
Okay, if you count that, it's not 6. It could be negative number as well, right? So it can be a lot of things. So think about it. 1, 42. 2 times what? 3 times what? Nobody knew this one. 14. And that's 6 times 7. Of course, they are reversed, right? So they are 8, but they also can be both negative. So yeah, there's a lot of combinations, right? So there's no restriction anymore. There's a, and like you said, there's could be decimals, right? Because I could just say it's 2.5 and then 42 divided by 2.5, which equal to the other number. So there are infinite amount of choices. So same thing like this. Sine of x equal to square root 3 over 2. There's also infinite amount of answers here. But first of all, let's talk about particular solution, which is 0 to 2 pi. How many solution between 0 to 2 pi? 2. Yeah, so some people just say, I can inverse both sides. You're not supposed to inverse on both sides. Because if you inverse, you create restrictions. Right? Some people say inverse both sides. Oh yeah, the answer is pi over 3. I say, wait, you just restrict yourself. There is no restriction on sine of x equal to square root 3 over 2. So essentially, you are saying, well, x is equal to not only pi over 3, because x can also equal to 2 pi over 3. Result is going to be exactly the same thing. So this is called a particular solution. We're going to hear this word in terms of calculus as well. So particular solution is going to be x equal to pi over 3 and x equal to 2 pi over 3. Now, it turns out there are infinite amount of answers. Why? Because you think about sine of x graph, it's like this. Like this, keep on going, right? And square root 3 over 2 is right here. That's square root 3 over 2. There's an infinite amount of intersection, infinite amount. So that should be pi over 3 plus, well, the periods. Because each period is going to create a new set of solutions. The period is going to be 2m pi. And 2 pi over 3 plus 2m pi. And that would be the answer for this particular one. And this is called a particular solution. And you're done. Got it? Pi over 3 plus 2m pi. M pi, n means natural number, but natural number is not really good because natural number doesn't include negative. So in this case, n is for all integers actually. So negative numbers counts integers. Yeah. Fancy z, yeah, that's actually z looks like this. That's integer, yeah. Very good. You actually know your number. No, most of people doesn't know the difference between rational number, irrational number. What's the difference between rational number and irrational number? Rational number just could be anything with a fraction. So it could be 1 over 17. and that's rational number. Irrational number, you're right, square root 2. Give me another example of irrational number. Good. Another one.
Square root of anything that
Probably true. One more. Very famous one. Yep, good. You got all the things. Okay, Euler's number. I think it's pronounced as Euler. So, but I don't know. I could be wrong. I don't speak whatever language that is. German, maybe? The German? Sound like German. Okay, so does that make sense? Okay, so now I'm gonna ask you to solve equation now. 3/10 of x plus square root 3 equal to 0. I want you to solve for x between 0 to 2 pi. And then, so first thing between 0 to 2 pi, the second thing is general solution. Now there was something, hopefully you remember. One, two, three, four, five, six. Start with 26 kids. We're done with 16 kids. 17. Taiwan's still here, yeah. He's like, I'm not here for long. Ha ha ha. No, you're okay. You survived this long. You can survive another half, 3/4 year longer. What kind of confidence is that? I don't think so. Your retest is next Tuesday. Now, the reason why I give you a retest is most of the test score are low. But remember, you're not qualified to retest if you miss homework. So Lucas, you already missed a homework. That means you can't retest. You have no excuse. I handed the homework to you yesterday. Make sure you stay on top of the work. Let's figure out the solutions. Avinash, what's your solution? How about general solution? Does anybody want to make adjustment to that? Ethan.
You don't have to have a separate from each other. You just have 5 pi over 6 plus integer
M pi. Now, why is M pi? Your teacher told you why is M pi? Because the period for tangent is what? Pi. So be careful because tangent for period is pi. So 3/10 of x is equal to square root 3 negative 10 of x equal to negative square root 3 over 3. Now, for me to figure out what's negative square root 3 over 3, I'll figure out what happened here. And I said, okay, well, I know 3 things. One is tangent of pi over 4 is 1, right? Tangent of pi over 6 is always square root 3 over 3. So this is in term of pi over 6. The other one is square root 3. Here's square root 3. So therefore it's pi over 6, but it's negative pi over 6, but it's not restriction. So negative pi over 6, 11 pi over 6 is the same answer. And x equal to 5 pi over 6, that's another answer. Now, if I want to figure out what is the general solution, so 11 pi over 6 plus m pi, x equal to 5 pi over 6 plus m pi, because you are going to get some type of things going on.
Wouldn't it just be negative and try
Because if you plus m pi will cover everything, because you could subtract m pi as well. So they will cover everything. It doesn't matter what. And you want to start with the general particular solution, which is 8m pi over 6 and 5 pi over 6. And what you do is just plus m pi on all of them. It should cover every solution that possibly can be.
So that would be wrong.
It's not wrong. It's part of the answer, part of the general solution, but it's not part of particular solutions.
You can just say 5 pi over 6 plus m pi and 5 over 6 plus m pi, or just the 5 pi over 6 plus m pi.
That's a good question. You need to do both, because I'm gonna create a situation that you need to do both, and that situation is called multi-angle trigonometry equations. So that one is usually the hardest one for kids to figure out. Yeah, it's best to have just including both. Is this okay? Now let's go into a little bit harder. Now I'm reviewing algebra 1. Believe me, I am. Please don't mess up algebra. I beg you. Marcos Pizarro is in BC Calculus. He missed this question 4 times last 2 years. Anybody know Marco Pizarro? He's a funny guy. What? Cosine square x minus 1 equals 0. The thing he messed up is not even messed up trigonometry. Messed up algebra 1, so. All right. How many solutions you got?
Solution or for the
Particular. You fail algebra. Come on, think. Tick tock, tick tock, tick tock. There are 4 solutions. Yeah.
I did it, and then I was like, okay, 1, 2. Yeah, that makes sense.
Plus minus.
I did the difference of squares, and then I just.
You don't have to do defensive square as well. So that's just a simple equation that you can solve. You can do it this way too. Difference of this equation, you can also do the same thing. And you can solve that. So it turns out 4 cosine square of x right? Plus minus. Square root both side, plus minus. Cube root both side, positive. Questions? Good. Yes, Marilyn. If you want a general solution plus 2 and pi, yes. Okay, so I'm gonna give you a little bit the twist of the questions. Okay, so this question a little bit of twist. You also needed this part of algebra, so I'm gonna teach you if you don't know how, but you do need to know a little bit of trig here. Did you guys get all the solutions? No?
Score again.
Yeah, but this one is a little bit twist, flat turning in the middle, but it should not be too difficult if you just understand a little bit of algebra. Okay, so so that's equal to 2 over square root 3. Now the problem secant is what? 1 over cosine. So here's the trick about algebra is this. You can actually flip both simultaneously. You can flip both sides. This is how proportion identity is proportional. So you can flip this side cosine of x equal to square root 3 over 2. Now you become something you're familiar with. And then x is equal to all the pi over 6, right? And that's it. The test, you can do that? Good. Next question, I want to give it to you. Again, everything is all algebra. I'm just reviewing your algebra skill. I want to solve this. What do I remind you of? Quadratic factoring. Okay, what can I do? First step. Nope, don't take out effect sign yet. Move the 2 over. How is that equation equal to 0? Am I going too fast? And this is why a box method is very good, because it's very showing what happened. Sine of x, 2 and 1, 2 sine of x and sine of x. Which one need to be negative? 1? You're absolutely right. Sine of x minus 1 times sine of x plus 2. So sine of x is equal to 1, x equal to pi over 2. Sine of x plus 2 equal to 0. Sine of x equal to negative 2. What is x here? No solution. So this is the only solution. Because the graph of sine of x can never reach 2. So this is a 1. This is a negative 1. 2 is right here. There's no intersections. So if anything greater than 1, it doesn't work. What time we get off? Oh, good. We're going to go to another fun one. This one's a little bit hard. Define fun. Now the question of this one is more difficult than the other one. This one's probably one of the harder one. There's a lot of room to make mistakes here. But they're very important. What's the first step? Huh?
Is it equal 0 or just substitute for the sine 2x?
Okay. Either one. Anybody can raise hand, tell me what the sine of 2x is? You just passed that test, hopefully. Or the sine of 2x. Replace that with 2 sine x cosine of x equal to sine of x. Oh, that's hard. Now the next thing that people make mistakes. So I will tell you what kind of mistake people make. It's pretty funny. So I'm going to show you. But for next step, what do you do next? Do not ever divide it by sine. Now I'm going to show you why you do not ever divide it by sine. So for example, x squared equal to x. This tells me there's two solutions. But if you divide it by x on both sides, what happened? This is wrong. Now, what is supposed to do? You can factor out x. There's two solutions. It turns out in trig, you get a two solution if you just divide it by one thing. So does that make sense? What can I factor out here? Can I say sine of x equal to 0? Obviously 0, pi, even 2 pi, but I don't think that's within the range. 2 cosine of x minus 1 equal to 0. 1/2 x equal to pi over 3. 5 pi over 3. So it turns out you got rid of two answers here. You cannot see? How about now? I just teach you how to solve all the trig equations. This is the last stage of the trig. Oh, actually, I still have two more questions, Nicole. But that we'll talk about tomorrow. Today is a lot of information. Well, it depends. Sometimes I say including 2 pi or not including 2 pi. But if you're including 0 to 2 pi, then you have 5 answers there. So you got rid of all 3 if you divide it by sine of x. So don't ever divide both sides by something unless they're constant. Questions? Is that a lot of information or this is not too bad? Manageable? No? Is it hard?
No, I just. Yeah,
Lucas.
So I like my vague knowledge of it.
Huh? Already posted. Oh, it will be posted if
Yeah,
I.
get homework done today.
Huh?
Get homework.
I don't trust you. I don't. People can tell me things. Huh? No. What's your parents' phone number? Your mom or your dad's worse?
If you pick, they're both pretty pissed.
Yeah. So which one? You pick your poison. Okay. So what's your?
7,
Uh-huh.
7, 0, 3, 3.
Okay. What's his name?
Carlos Ulysses.
What?
Carlos Ulysses, but people call him by his middle name, Ulysses.
Okay. Well, we'll see. You call out them. Here's the homework. Take a picture of this because you don't have what's up yet. Oh,
Is that the worksheet you sent it for 2 days?
no, that's already done. You're gonna go through this all, then go through this odd, and go to from here to here odd. So from here to here, and from here to here, and from here to here odd. Odd problems.
Thanks, Mr. J.